Hello everyone, and thank you for joining us for another video tutorial. We created a new playlist, and in this playlist we will learn and understand how the World Wide Web works using the Microsoft Stack and then build a website from scratch. Here's what we're envisioning. We have downloaded some of the Bootstrap examples and we will use it as a template to build a blog website. As you can see, we have the home page. And then as you select a blog, you will see the details of that blog post. There are plenty of blog engines out there, and some are the same technology. This is not an example of creating another blog website. This is an example to learn from by doing it from scratch. You can see the recent blogs and it's a listing, and then you have navigation at the bottom where you can go see previous blogs or go forward again and see the latest blogs. We also have a search functionality where you can enter some keywords, and then if there are hits within the blog, we will return the blog post and display it to the user, and still give them the functionality to be able to forward and paginate back and forth. We will be able to tag and use categories to further group the blog post. And finally, we have a list of years and current year's month for quick navigation, so you can see how many posts were made for a specific month. If you click on a year, then we show the months. If you click the months, we will show the post for that month. So before we start our journey, we need to have a good foundation and understanding what we need in order to get where we want to go. So as a web developer, you need to have a strong understanding of HTTP protocol. So when things go wrong, you can debug and fix and figure out what happened. Next, you need to understand how the pages are built, what kind of markups to use to display the page, what are the buttons, text boxes, and other things. Once the page is displayed on the client side, you can create events to listen to the user's actions and change the page based on what you want to do in the user's browser. Then we will learn how to make the page pretty so that they look nice. So it's not just a generic button. You can put some features around it to where you can change the color, the text, and put images and other things. A web page rendered on the client side is generally referred to as front end. When the page makes a request to the web server, for example, the user makes a search query, we have to take the query and search the database, then generate a page on the server with the search results, and then have the web server send it back to the user. This is our backend, all the work that happens on the server. You can also have another layer in the middle that can be an API. And you do this, for example, to extend your application to have external sites to be able to query and search your blog post so that they can display the results of your blog onto their website. And for this, you can create an API that will be a middle layer. We can use any number of technologies for doing this. Finally, we need to be able to store the data like our blog post and then be able to display that. So for this, we will use a database. When developing web pages, you need tools to help you debug and analyze statistics of the page so you can make better pages. Next, we need to figure out what technologies to use to build our website. For our example, we will use the Microsoft Stack, and for the application, we'll have a blog website. Now that we have a clear vision of what it is we want to do, let's learn how the web works and get a basic understanding of the HTTP protocol. Let's talk about HTTP resources and what they are. When you open your browser and you want to search, you enter https://www.google.com. Your browser makes a request to a server, google.com, and then the server responds and displays its resource. In our case, the home page where we can search, so that the address we entered, http://www.google.com, is a URL. It stands for Uniform Resource Locator. It represents a resource. So the HTTP is a URL scheme, the protocol that your browser will use to generate a request. And then the server will respond and provide you the resource. Here we can see that we are navigating to google.com, but we use HTTPS. HTTP with an S, the secure method to make requests, meaning that the request and response will not be readable if someone was to intercept the request, whereas an HTTP is clear text and anyone can see the data. We will use Fiddler to see the encrypted versus clear text data. Fiddler is another tool that you can use to debug HTTP and as a proxy. What that means is that it sits in the middle and monitors all HTTP requests and captures them from your server and sends it on your behalf to the server, then takes the request and sends it back to the browser. And that's how we can see the HTTP request and response. If your browser supports it, we can use the protocols like file and or FTP. The www is a prefix and can be omitted if the website supports it. This has to do with an entry in the DNS, and we'll talk about DNS in a moment. Next, google.com is the server we want to reach. So how does the browser know to find google.com? Google.com is human-readable text, but computers don't understand that text, so it needs to translate it to an IP address. All computers have an identifier. Here's our computer configuration. This is a very brief and basic review of how a browser makes a request to a server. The address can have additional values. For example, if we go to one of our sites in the browser and we click a link, notice that we now have additional values after .com. Which brings us to the other part of the URL, the .com. The .com is a top-level DNS and represent commercial organizations. If we want a government site and the state we are living in, it would be www.ca.gov. .gov represents government organization. These are not the only ones, there are many more top-level domains. Back to our values after .com. In our site, we have issue $ID equals 2. Issue is the resource path. The question mark is the starting of a query string. So the first part of the URL takes us to the server, then the resource path points to the resource that the server should get for us. The query string and a dictionary value, ID is the key. and 2 is the value. In our example, we are asking the server to get an issue ID of 2. We can change that and get a different issue. If you have more than one query string, they are separated with an ampersand. You can also have a pound at the end of the URL where it will show us a location in the document. In our example, we're not using one, but if we did, the page would scroll to the area in the URL. Now that we have a basic understanding of HTTP resources, in this section we'll focus on HTTP messages. HTTP messages are how data is exchanged between a server and a client. There are two types of messages: a request sent by the client, which could be your browser, or you could actually code this yourself to trigger an action on the server, and then the server will respond with an answer. HTTP messages are composed of textual information that are encoded in ASCII. There are multiple versions of HTTP, but it really depends on what the server can accept, and we'll see this in a moment. You rarely have to create textual HTTP messages yourself. It's a good idea to review it to better understand it. So let's take a look at how to construct an HTTP message. Let's go back to our Fiddler and compose an HTTP request to our website. If we select the Raw tab, we can see the textual HTTP request. We use a get verb, more on that later. Then we have the URL and then the HTTP version. There are many versions, but ultimately both the server and the web browser must support the same version. We will use 1.1. Next we have host and content type, which are not required for this request, so we can delete it. Now we have a very simple GET request. When executed, we get back a response from the server. This is our request message. This request has the HTML text a browser can display. Let's see different versions and see what happens. So it looks like the server can handle HTTP version 1.2, but when upgrading to latest version 2.0, we get an error from the server. So the server cannot process our HTTP version 2.0. Now let's capture the browser's web request by refreshing the page. As you can see, the browser has a lot more detail for the GET request. If we look at the raw request, we can see a lot more values. But we stated that HTTPS is secure and should be encrypted. We have configured our Fiddler to extract the HTTPS values so it acts as the man in the middle. It captures our web request, then packages it and encrypts the data and sends it over the network. When the server sends a response back, Fiddler knows how to decrypt the data and send it back to our browser. The HTTP response looks similar to our request, where we start with the HTTP version and the status that the server was able to process our request, and the status is 200. Next we have a content type and the server sending us text HTML data in the body of the request. HTTP can handle many types of content like images, XML or JSON, and many more. Next, the server is running IIS version 10 and it supports ASP.NET. We also get the server date and time as well as the time zone. Finally, we get the content length, which is the length of the HTML body. The space between the lines starts the body of the request. Fiddler also makes it easy for us to see by putting this data into a structured grid. Let's navigate back to our site and utilize the browser developer tools. You can get the tools by either using the shortcut key or navigate to the menu, then use more tools, then developer tools. In order to view the messages, navigate to the network tab. Now let's refresh our tab and we will see many requests. Let's find the GET request for the home page, then select it. In the header section, we can see both the response and the request message. So the developer tools for the Edge Chromium is a great place to start your debugging and reviewing how HTTP messages work. And as you can see, we have many other requests like images and fonts. There are primarily two HTTP verbs, get and post. And the difference are the HTTP get verb is to get a resource from the server. The HTTP post is used to send data to the server, then have the server act on it. Let's see that in action and doing a search on the site. When we enter a keyword that we want to search, we need to send that data to the server, so we can use post. So if we look at the request, we can see that we have an additional data called form data. The browser is making it easier for us, but this data is textual as part of the request, and we'll see that in a moment. So the post still uses the URL. In our case, we are posting to a resource path, search results. Now let's take a look at the same thing, but in Fiddler. As you can see, we have two values that are sent over. Search text is the keyword to search, and an additional value used to make sure that we are not cross-posting. More on this when we get to developing our blog site. Looking at the raw request, we have our post request, then the URL, and the HTTP version. We then have a space between the lines so that the post data is sent as the body of the request. If we inspect the page and drill into it, where the text box is, we can see that text box ID is the key and the data is the value. Then we have another input, but it is hidden. More on this when we discuss HTML. Let's head over to Google and see how they do it. They use a GET and not a POST. This means that the key for the text box and the value will be in the URL, since a GET does not send its data in the body. That is the difference between a get and a post. So you can still use a get by sending data in the URL, but in post you would send that data as part of the body. You can still send additional values in the URL. Let's clean it up a little bit so we can see the URL more clearly. And now we can see the pound value is encoded due to security reasons, and we'll review this later on. The encoding plus represents a space, and the C %23 represents the pound. So we can use Fiddler to capture a request, then study it, and create our own HTTP messages. Let's summarize what we've gone over and how HTTP messengers are packed. We looked at two methods, get and post, where get sends data in the URL and post in the body. When a message is constructed, we start with a method, then the URL and path to the server, and then the HTTP version. Then we have some values in the header. We'll discuss this in a moment because we haven't gone over the headers. After the headers, we have a blank line, then the body. The body can have many types of data, but so far we've seen key pair values. We will learn more about the different types of data we can send in the body when we work with HTML in the next session. Back to the HTTP headers. The headers contain additional instructions for the server for the request message and the client web browser for the response message. The HTTP headers host is the only required value, others are optional. In this example of an HTTP request, we're getting a resource from Google with an HTTP version of 1.1. We have our required host header value, and we accept HTML and text values, an indicator to the server on the response that we would like to have HTML sent back to us. The HTTP response message is almost the same except the first line. We get back the HTTP version that the server is using to send us a message, then a status of a message. If the server was able to process our message, we get back a status code, then a text message describing the status code. We will learn more of the status codes when we develop our blog website. The header section is a response to how the browser should deal with the response message, and finally the response body, which is usually HTML, as we've seen so far. If we look at the example of a short response, we can see that our request was processed as we got a status code of 200 and the message of OK. In the header, we get some information of how long we should be caching the resource and the type of message we're dealing with. In the body, we have a simple HTML page. So this was a very quick review of the HTTP resources and messages. Let's take a look at the HTTP connections. To understand HTTP connections, let's answer a question. How does HTTP messages traverse over the network? To understand this, we need a little bit of knowledge on network programming. TCP/IP, which stands for Transmission Control Protocol, Internet Protocol. TCP/IP is a set of standards that allow computers to communicate over the internet. The network card in your computer is responsible for sending a request to a remote server and has multiple layers. Each layer and the stack has specific responsibilities. When the browser sends an HTTP message over the network, it will not specify how it should do that. HTTP, as stated before, will only compose the HTTP message. This is where the layers and the network stack comes into play in sending that message over the network. The application layer is used for interaction between user and the browser. The transport layer packages the HTTP message for delivery. Then the network layer readies the transmission of data. The data link layer is responsible for node-to-node delivery of the message. If there are any errors, it will resend the data. Now let's examine if we were to send a message to Google, how we would generate that over the network using the browser. To do that, we would have to communicate with other computers using the network. And C#, the system.NET namespace, allows us to write low-level program to communicate over the network. To see this action, we need to create a simple console application that uses .NET Networking API. So let's go ahead and start with creating a URL, but without the HTTP, as we will generate the HTTP message ourselves. Next, we want to get the IP for the host we want to reach. So we'll go ahead and use the DNS class, which resides in the system.NET. We'll call the get host entry and then pass it our host. This returns us a host entry object. And now we need to get an endpoint. So we'll go ahead and pass the host entry, but it returns multiple IP addresses. So we're just going to use the first one. We also need to pass the port. So we're going to go ahead and use port 80. So now we're going to go ahead and create a socket. Let's go ahead and add the namespace. So let's go ahead and now generate our HTTP message, and we're going to make sure that we have our required host header. So now that we got our HTTP get and have our HTTP, and then we'll put the version. And the resource path we want is just going to be the /. This will indicate that we want the default page that Google has for their homepage. And now we're going to go ahead and have the required host. And we're going to go ahead and terminate it by having 2 new lines. So that was our HTTP GET request. And now we're going to connect to our socket. By passing our endpoint And we should do lowercase because we want instantiated object. Now that we connect it, we want to send the GET request. But we need to send the GET request because it's in clear text. We need to send it as a byte array. So we'll go ahead and use the encoding class. And make sure that we get the ASCII get bytes and pass our get string. So next we just need to go ahead and create some variables that's going to hold some values, like a Boolean value if we're still reading the header, and then some other variables for stuffing the header response that's coming back, as well as the body. And let's go ahead and create a content length default of 1024. So let's go ahead and loop until we have the heading values. Let's also go ahead and put this into a try and catch to catch any errors that we may generate. And let's go ahead and create a header buffer. This is going to be, we're going to read 1 byte at a time. And then we're going to receive from the socket. And then, of course, we're going to convert this 1 byte to a text afterwards. And let's go ahead and add it to our header string. And we're going to go ahead and use the encoding ASCII class again. And so now we're going to check to see if the header string has the the blank line that we were talking about between the headers and the body. So we'll look for 2 blank lines. So once we reach that, we know that we are now in the body. And let's go ahead and read that. We'll just do the same thing as we did with the header. We'll receive from the socket, and but this time we're gonna receive 1024K of bytes, and then convert that to a string and stuff it into the body string object. Okay, so let's go ahead and close out our socket properly. And now that we have everything finished up, and let's execute the program. If we did everything correctly, we should get both the body and the header, a response object, coming back. So this is how we can send raw HTTP message over the network. Microsoft does have an HTTP client that we can use. It'll abstract all of this for us, so we don't have to worry about creating raw HTTP messages, and we just have to worry about having a program that can send data to a website and then receive some results back. We started with HTTP connection and made a detour on how the network layer sends raw HTTP messages. Then we showed you how we can use networking APIs to do the same thing that the browser would do. Now let's take a look at what the HTTP connections are. There are really two types of connections: keep alive and close. When sending an HTTP request, having to open sockets and close them every time takes time and is expensive in resources. In HTTP 1.1, the default of an HTTP connection is keep alive. What this means is that we do not close the connection and we can use it again. If we state close, then the socket will close and we would have to reopen the connection if we wanted to make another web request. We can see that we have an open connection by running a network command netstat-a. This will show us all active connections from our system to remote servers and the state of the connection. Now let's ping our site so we can get an IP address of the remote server that we were connected to. Now let's go back and watch our connections. And here we can see that we have a secure HTTPS connection established to our site, and the connection is open so that we can reuse this to make additional requests to that website. HTTP does not concern itself in what tech stack you use. Let's take a look at two examples. We have created two websites. One is using Node.js and the other is using .NET MVC. So we'll go ahead and launch the web.js. So as you can see, the web page is loaded. If we hit F12 and go to the developer tools in our browser, let's go to the network section and just refresh. As you can see, we've hit our local host. We have our response and request headers. And of course, we have the body being displayed here. So if we go view source, and this is the HTML that's coming back from the web browser. So now let's go ahead and stop this and go ahead and execute our MVC. And once again, let's go ahead and hit F12 and go to our developer tools, and let's refresh this page. So we got our response back, and we have our request header and response header coming back, and everything is okay. Now let's go ahead and view source, and as you can see, we got our HTML back. So we can see that HTTP doesn't enforce what tech stack or a specific technology that you use, and architecturally HTTP uses URLs to reach a resource on the site. Then the message headers and the body can have intent of what the client needs, and the server can then process the intent. So if we take a look at example of this web page, we made a GET request for the server on the specific port, and this is the resource that we want back. Most likely it will be the default index or whatever the default home page is. And so if we look at the request headers, we are accepting text HTML as well as XHTML and XML. So we're basically saying that give us this resource and return back, and we actually accept HTML or text. We also have some gzip encoding that's happening here with the language and cache, and we have some cookies and a bunch of other information that we can go over that later when we actually designed our blog website. So and if we look at the response header, so this message went to the server. The server read our message and the URL, and it generated a response, and this is the response coming back from the server. And this is the resource, which was an HTML page, but we also have additional requests that we made from this resource. If you look at this, we have some styling sheets in here. We may have some, we have a icon, and we have, let's see if we have any other resources. So that's pretty much all we have in order to display the page for us. And if you can see, we made subsequent calls based on this message that we got back from the server to go and get our CSS from here. And there's a jQuery values coming back, and there's a favorite icon which is being displayed here in the home page title. This was a quick example of client and server interaction using HTTP messages. What if we wanted to secure a part of our website? HTTP doesn't have any mechanism to secure a website, nor should it care. Remember, HTTP just passes along messages, and the server acts on the client intent. Here we've added one more site that handles security. As we log into our site and navigate to other parts of our site, it will remember us. So as you can see, the site now remembers who we are. And it has the secure page that we can get to change our profile information. So how does HTTP do this? Well, if you look at the inspect the HTTP message, you'll notice that we are going to the login page and we're posting some data. So if you look at the headers where we're posting that, which is part of the body, the post data has our email and our password as well as some request validation be sent to make sure we are sending data from this page. And then on the server side, the request is processed, and there is code on the server that will authenticate the user against some database. It's not important to see that code now, because eventually we will write the blog posts website to where we can post our blog information, which requires us to be logged in as administrators. So we will see that later on. But this gives you some details of how security is handled. So in the headers, we have some cookie information, and the cookie information is where the information for this user is stored. What happens, the server, when it processes the username and password and authenticates us, it will write a cookie, and the cookie is encrypted so that you can't modify or update it. So as we go to navigate to a different page, that cookie that was written is read by the server. So here we went to the manage page. So if we go here, the cookie information is passed along as part of our request. The server then reads the cookie that we need. It will validate the cookie to make sure we are who we say we are, and then if it's successful, then allows us to come into the page. So the web is stateless, meaning that all the messages will have all the information we need to go and have the server process the request. But the way we can keep the state is to stuff data into the headers. Here we stuffed it in the cookie. We could have actually created our own header values and added information in there. And we'll see how to do that later on. This should be a good overview of the basics of how HTTP works. Here's a quick overview of what we will learn in the upcoming video tutorials. HTML, the thing that makes our web browser render the text and images and other resources. CSS for styling our HTML to make it look much more better than it is. JavaScript and WebAssembly to manipulate and interact with our HTML on the browser. SQL databases, a quick review of what databases are and how to design our blog engine to store our blog posts so that makes our website more dynamic as we read, post, and search for them. ASP.NET MVC with C#. Here we will learn how to create dynamic websites on the server. Thank you again, and we'll see you in the next video tutorial.